architecture traditionally is a practice by demand, right? So you cater to a specific question of a client, and therefore we can't sort of develop technologies that will use a few times over, right? So by implication, by this kind of demand-driven practice, we can't invest a lot of time and energy in the development of certain design methods, fabrication methods. So the thing is that that is also to do with that maybe a good practice builds 1 in 10 designs. So imagine that all this entropy, all this energy that hasn't culminated in build work, that energy is invested in methods of fabrication. I see architecture increasingly as a really banal idea, where you have the market value of the built artifact, the building, the house, skyscraper, whatever it is. And so if you subtract the building materials, the labor that was sunk into the project, if you subtract it from the market value, what is left is architecture. And you know, somehow architects haven't really subjected themselves to this harsh reality of capitalism, right? That our task is to inflate this discrepancy, right? So when you can, new technologies are the way to inflate this discrepancy. The success we had with some of our chair designs project was that at that scale, CNC technologies, robotic fabrication worked out for us. And it turned out that at the building scale, it worked. The lack of those means, the lack of robotic technologies not scaling up to the building skills really worked against us, right? So we wanted to close that gap. What we've achieved with Odico is sort of bringing robotics to primary structure, where, you know, the molds that we produce are being casted on site, right? So I think robotics have this kind of interesting niche of being, we have this stark duality in construction, right? Either things are built on site, in situ, or they're prefabricated. And maybe robotics can be a sort of in between, right? So by example, if we build molds in our factory, ship them to the construction site, and they are produced, you know, they're cast in situ. What is that? It's kind of in between of prefabrication and on-site building. The thing is that we are at a very joyful moment, because let's say, I've been also always very skeptical about concrete printing. Like, when you think of it, okay, in traditional architecture you basically have horizontal surfaces and vertical surfaces, right? You can't do anything on horizontal surfaces. My suspicion my idea for concrete printing was that it's kind of an extruding process, so that sort of the forms it allows to be produced is somewhat limited, and it still implies a lot of manual labor to get these. I mean, all of this layered structure of the 3D printed output has to be rendered at some point, right? So I don't know, I think our way of working has been incredibly pragmatic, and that's why we've seen quick industry adoption, right? We don't have to think of how we're going to combine additive processes with rebar, with finishing, like, right? It's congruent with existing methods. So let's push forward what can be achieved, right, in build work. And I think robots are incredibly empowering in that sense, right? And it is easy to get a little bit fatigued by the fear mongering of, you know, losses of jobs and so on. So when you look, for instance, in the US in the late 90s, right, such a huge number of the population worked in agriculture, 70-80% or something, and now it's 2%, right? So the mechanization of agriculture is kind of the foundation that allowed society to leap forward, right? Modernization came after. The mechanization of agriculture is essential to modernism, right? After that, Ford came and sort of cars became commonly available, but this mechanization was an important leap forward. So that is kind of, I think that's an interesting historic perspective. And how that will play out to an architecture, it's exciting.